Hello my dear, I welcome you all in this series of PYQ of SSC JEE. In this series, we will discuss the subject of thermodynamics PYQ. And this series is very important who are preparing the SSC JEE GATE examination. And in this session, we discuss the questions, only questions of PYQ. The subject is thermodynamics. And in this series, we will not only give the solution, I will also provide you the background of that solution, so that you much more confidence about that theory part also. So this session is indirectly we have to explain all the detailed manner of the solution. So really this session is very helpful to you. And really if you like this video, if you like this video, if you enjoy this lecture, so it's my humble request, please subscribe, share and like the IMS GATE Academy channel. Okay, so we start with the problem. So the problem is, this problem in this session, it is approximately, the time of the span of this session is approximately 1 hour, and thus in this 1 hour we will discuss approximately 20 to 25 questions, and it will approximately 3 sessions. So 3 sessions. So we cover approximately 100 questions of thermodynamics and its application parts. So this series is very, very helpful for the mechanical student who are preparing for the SSC JEE examination, and the subject is thermodynamics and its application. Let's start the subject. Now, my dear, this is the first question. What is the first question? Please read this question. I will first read this question. This question is for 2022, SSC JEE 2022. So what is that? In figure shows that PV diagram. There is a P and V diagram, pressure and volume diagram of an ideal gas. So this is your ideal gas, okay? This is your ideal gas. This is your ideal gas, okay? This is your ideal gas. And you know that what is the property of ideal gas? You know that what is the property of ideal gas, my dear? Ideal gas, that means PV is equal to MRT. PV is equal to, what is the equation of the state of ideal gas? Equation of the state of ideal gas, pressure into volume is equal to mass of the gas, R, gas constant, into T. And mind it, pressure is always in absolute pressure. Absolute pressure generally in kilopascal. And volume, it is in meter cube. And T, which is very important, student get confused sometimes, this T is always in Kelvin, okay? So this is the work done by the gas in this process A, B, C, D, A. A, B, C, D and A. So this is the process. A, B, C, D, A. This is the process. So what is the work done? So work done. So this they are asking the work done during the process. Work done during the process. So my dear, we know that work done, that means we have to find the net work done during the process, and net work done is equal to summation of the work during all the process. So you add this is the area, that means area of this curve. So just you have to find the area, and that area gives, that means area on PV diagram. PV diagram. And the diagram, PV diagram, this is pressure and volume diagram. So find the area of this diagram, simply find the area of this, and this diagram is trapezoidal. Okay, so what is the area of this diagram? Area of A, B, C, D. This is your parallelogram. That means area of parallelogram. What is that? We know that half summation of these two, that means AB is AB plus CD into distance between these two. And what is the distance between these two? Perpendicular distance, BC. BC. Put the value, half. What is AB? AB is what? 2V minus V. 2V minus V plus CD. CD is what? 3V minus V. 3V minus V into BC is what? 2P minus P. So how much it is? If you resolve, this is half V plus this is your 2V. That means, so V plus V, that means half 3V into P. So how much it is? It is your 1.5 P into V. And this is the option in these questions. So this is your answer. If you have a pressure, if you have a value, multiply it, find the work. So what is the motivation and what is the thermodynamics work, beta? Thermodynamics work during the process 1 to 2 is equal to integration V1 to V2 P dV. Mind it, this is the thermodynamics work. And this basically work is the displacement of a boundary. That means if there is any expansion or contraction is there, so what is the boundary, what amount of work will be done by the system to the surrounding, that is your P into V. And here P is not constant, P is the function of V. So if you have a P and V relation, you can easily find the work done, 1 to 2. Okay, and if you find the net work done, that is your area of the curve. Area of the curve on the PV diagram. Okay, so this question is finished. Now, the second question is also in 2022. And what is that? If the specific heat ratio of the gas, this is your gamma. Specific heat ratio, that means gamma, it is given Cp by Cv. Specific heat ratio. The change in internal energy of a mass of a gas at a constant pressure P. That means you have to find the change in internal energy at pressure is constant when the volume changes from V to 2V. That means this is state first and this is state second. So we have to find the change in internal energy. The change in internal energy. We have to find change in internal energy. How to find, my dear? And here is pressure is constant. Pressure is constant, that means what is the pressure of 1 is the same as the pressure at 2. And what is the volume 1 is V. What is volume 2 is 2V. So this is a state first, this is a state. So state first, the pressure is P1, volume is V, pressure is P2, and this P1 is equal to P2, it is given, volume is V2. So we have to find change in internal energy. So what if we know that, beta? We know that the change in internal energy, see, this is important question, this is a good question, very good question. What is that? See, change in internal energy, U is equal to mass of the system, CV into delta T. For this is for the ideal gas, okay? So mass of the gas, CV, specific heat at a constant volume into delta T, okay? Now here Cp and Cv relations, it is equal to gamma, it is given. So we don't have a Cv, the Cv value we don't have in the form of that one. So one relation is what? Cp by Cv is equal to gamma, and second relation is what? Cp minus Cv is equal to what? From this two relation, we can easily find what is the value of Cv. So Cv is equal to R divided by gamma minus 1. R divided by gamma minus 1. Put this value back here. So, my dear, see that what is ideal gas? PV is equal to mRT. So, beta, mass is constant, R is constant, pressure is constant. Pressure is constant, it is given. So, V is equal to some constant K into T. This is like that. Then V directly proportional to T. V directly proportional to T. So if you write like that, so what is the delta V? If you write delta V is equal to K of delta T, you can write like that, K of delta T. So here mass is there M, CV, M, CV, and instead of delta T, you put delta V. Why? Because delta T is directly proportional to delta V. So we have to write that. MC and this T, change in temperature is equal to change in volume, and change in volume is equal to V minus V. Now M, what is CV? CV is equal to R divided by gamma minus 1 into V. So what is this value? And what is that, beta? This is what? MR and V directly proportional to T. V directly proportional to T. So instead of, here we have to write T2 minus T1. T2 minus T1, and T2 is what? T2 is what? At the T2 is your V2 and T1 as your V. So T2 is V2 and V. So V, and V directly proportional to T. So what is that? MRT divided by gamma minus 1. And MRT is what, beta? PV. So this is PV divided by gamma minus 1. This is the second option. So in this question, only these things you know that. Why? Because pressure is constant, so V directly proportional to T. V directly proportional to T. That means V directly proportional to 2. That means this is your T1 is equal to T and T2 is equal to 2T. That's it. That's it. So here we have to write 2T. Here delta T is equal to 2T minus T. 2T minus T is equal to T. So MRT by gamma minus 1. And MRT is what? MRT is PV. So PV divided by gamma minus 1. That is your change in internal energy. So during that, change in internal energy is your PV by gamma minus 1. That is your change in internal energy. Why? Because beta, the temperature will change. And internal energy for an ideal gas is a strong function of temperature. Strong function of temperature. So internal energy of an ideal gas is a function of temperature. So enthalpy is also function of temperature. What is the enthalpy? H is equal to U plus PV. So PV is the function of temperature, U is the function of temperature, so H is also a function of temperature. Okay? So enthalpy is also a function of temperature. Now, next question. The heat transfer in a cyclic process. Heat transfer. So there is any cyclic process. Let's suppose this is a cyclic process. Let's suppose this is a cyclic process. And heat transfer during the process is 20. Let's suppose this is your boundary. So let's suppose there is a one boundary, there is another boundary, there is another boundary. Let's suppose this is a different boundary. So 1, 2, 3, 4. 4 is there. So 4 boundaries there. So in this one, first, let's suppose this is first boundary, second, third, and fourth. Now, beta, first boundary, the heat positive. Heat positive, that means you can add the heat. So in this one, this is your Q1. And how much Q1? 20. All are in kilojoule. Q2, heat will reject. So in this one, Q2. And Q2 is how much? Minus 28. Q3, heat reject also. Why? Because this is also negative. Minus 2. And fourth heat is added, positive. So Q4 is equal to 40 kilojoule. And this is for the cycle. This is cycle. This is for cycle. So what is the first law of thermodynamics for a cycle? First law for the cycle. The cycle. First law for the cycle. What is the first law for the cycle? First law for the cycle, that means cyclic integration of dq, any boundary, is equal to cyclic integration of dw. We can write Q net is equal to W net. So my dear, here you have total work done during the process. So Q naught is equal to Q1 plus Q2 plus Q3 plus Q4, and that is equal to W net. So you have to find the W net by putting all this value. Q1 is positive 20, Q2 is negative minus 28, Q3 is negative minus 2, Q4 is positive plus 40. If you, and this is your W net. So W net is your, if you solve this one, this W net is your approximately 30 joule. So net is your 30. So for a cycle, net work, that means if there is a thermodynamics plane P into V, this is called thermodynamics plane, and let's suppose there is a process 1 to 2, and again the process 2 to 1. So it is a cycle. This is your cycle. What is the cycle? 1 to 2 via path A, one process, 2 to 1 via path B. So this is path A, this is path B. So if you take, this is the area, and in this area, how to calculate? You calculate W net. So this W net is equal to Q net, net heat transfer. So if you have a net heat transfer during the cycle, the total net heat transfer is equal to W net. This is called heat balance, energy balance. This is all. First law of thermodynamics, what the first law of thermodynamics is? Conservation of energy, that means energy balance. So first law thermodynamics for a cycle, first law thermodynamics for a process. So what is the first law? So if it is there, first law for the cycle is what? Net heat transfer is equal to net work transfer. First law for a cycle is what? For first law for cycle, that one. First law for the process, let's suppose process 1 to 2. So heat transfer during 1 to 2 is equal to change in internal energy during 1 to 2 plus work transfer 1 to 2. So heat transfer is equal to change in internal energy is equal plus work transfer. This is for the process. Though there are two things. This is for the cycle, and this is the first law of thermodynamics for a cycle. And what is the first law of thermodynamics for a process? So for a process, heat transfer during that process is equal to change in internal energy during that process plus work transfer. That is the first law of thermodynamics for a process. And this is for the closed system. Why? Because energy will transfer in the system to the surrounding. Either it is a mass, that means energy will transfer also due to the mass, and that is called open system. But in this case, the first law of thermodynamics, we have to study the closed system, that means energy transfer only by heat and work, not mass. So that is called a stationary closed system. So my dear, in this case, if you write like that, see, if you write like that, my dear, first law of TD of thermodynamics. What is the first law of thermodynamics? Conservation of energy. Conservation of energy, and that conservation is energy applicable for open system and closed system both. Now, energy in, let's suppose it is like that, energy in to the system minus energy out from the system is equal to change in energy of the system. So this is a transfer of energy. This is called transfer. This is called transfer. This is called transfer. This is called change. And the transfer, it is a boundary phenomena. And the transfer of energy, it is in the three form: heat, work, and mass. And change in energy of the system, it is in the form of generally internal energy. Internal energy. This is in the form of internal energy. Now, if the system there is only heat and work interaction, if in the system only there is a heat and work system, this is called closed system. Closed system. If the energy interaction between the system and surrounding both heat and mass or only mass, that is called open system. So if you write let's take example, energy interaction only by means of heat and work. So first law for a process, for the process, what is that? Let's suppose process 1 to 2. So what is that? Heat transfer during 1 to 2 is equal to change in internal energy plus work transfer 1 to 2. So my dear, heat and work are the boundary phenomena. Internal energy is the system property. This is your system property, but this is not a system property. It will be calculated under the area of the diagram, and this is calculated directly state change. If the state change, this will change. Okay. So that is, and for the cyclic process, 1 and 2 are same. So change, that means delta U, that means U2 minus U1, and 1 and 2 are same for the cycle. So that is 0. So if this is 0, so what is that? That means what is the W net is the same as heat transfer, net work transfer, or you can write during the cycle dQ is equal to dW. We have to cut. Why we have to cut here? Why we have to cut here? Why? Because this is a path function. This is a path inexact differential. That is called inexact differential. Okay. So that is the basic things of this all the questions related to this one. Now next one is this is the very fundamental concept of the first law of thermodynamics. This is a very basics level concept, a school level concept. Okay. Now next one, a gas is compressed in a frictionless piston. See my dear, frictionless piston, that means no loss. Dissipation is not there. That means irreversibility due to the friction is not there. That means the process is reversible. You can assume like that. And initial state is Y meter cube. This is the volume, and 1 megapascal to a final state 0.2 meter cube and 1 megapascal. There is a transfer of 40 kilojoule of heat from the gas. From the gas, transfer the 40 kilojoule of heat and a drop of 20 kilojoule internal energy. So heat will be transferred from the system to the surrounding. System internal energy drop. So drop is 20 kilojoule. What is the initial state of the volume of the gas? That means you have to find what is the Y value. That is also the first law of thermodynamics. Start. So my dear, what is the given state first? State first. What is given? What is the given state first? Volume. V1 is how much? Y meter cube. P1 is how much? 1 megapascal. State 2. State 2. What is volume? Final volume V2. 0.2 meter cube. What is P2? 1 megapascal. See, 1 megapascal and 1 megapascal constant is there. 1 megapascal. Okay? And during that, the heat transfer, 1 to 2 is, that means heat transfer from the system, heat will transfer, and that means if heat will transfer from the system to the surrounding, that is the negative. So this, say there is a transfer of 40 kilojoule of heat from the gas, and gas is our system. So system will lose the heat. That means this is a negative 40 kilojoule. okay, of the heat from the gas and a drop of internal energy delta U is equal to 20 kilojoule. Okay. So this is drop, so also negative. You can write like that. Internal energy decrease. So what is the first law of thermodynamics for a process? So first law of TD for the process 1 to 2. So Q1 to 2 is equal to delta U plus W1 to 2. Okay. So Q1 to 2 is how much beta? Minus 40. Delta U minus 20 plus work 1 to 2. So what is work during 1 to 2 is your minus 20 kilojoule. Work minus, that means work will add to the system. Work is adding to the system. So if this is a system, let's suppose, and if you add the work 1 to 2, that is your negative. And if heat will reject 1 to 2, that is also negative. Okay. So heat rejection is your 40, and that means energy lose 40, energy add 20, so its internal energy decrease. That means आप ले रहे हैं, that means you are taking more, giving less, so this system will decrease its internal energy, so decrease by 20 degrees, no problem. Now, if decrease, so you have a work. Now, my dear, this is the frictionless. That means the work is very important information I am telling you. Very important. What is the mean of frictionless piston? That means what is the meaning of the piston will be displaced frictionless? That means it is the internal reversible. It is the internal reversible. So for the internal reversible process, we know that what is the work transfer. For internal reversible process, beta, why? Because the process it is given frictionless. Frictionless, that means internal reversible. Internal reversible. And for the internal reversible, the work transfer between 1 to 2 is the displacement of a boundary. And what is the displacement of a boundary work? V1 to V2 P into dV. This is the, and what is the limitation? This is need not, very important information. 90% student confused here. Ki, sir, this work is applicable for the closed system. No, this work is also applicable for the open system. What is the limitation of this work? This work is for the displacement of a boundary, and the system will go under a quasi-equilibrium process. That means internal reversible process. Quasi-equilibrium process must be internal reversible process. But reversible process need not be a quasi-static process. Mind it. By God, reversible process may be externally irreversible. That means this, what is the limitation of this? What is the limitation of this equation? This equation is valid only for the displacement of a boundary work. This is what? This is the displacement of a boundary. That means if there is a boundary, system boundary is there, and if the system boundary is either expanding or contracting, and the expanding and contracting is under quasi-equilibrium process, during that this work will transfer. So here P is not a constant. So it is not necessary that it is applicable only for the closed system. That is very subtle concept is there. Many students confuse, sir, this work is for the closed system work. No! This work need not be applicable for the closed system. It may be applicable for the open system. Only this work is the displacement of a boundary work, and the displacement is under quasi-equilibrium process. Displacement is under quasi-equilibrium process. That is the things. That's it. Now, so what is the here see that beta P1 and P2 are same. That means pressure is constant. Keep outside. So P. So what is that? V2 minus V1. Okay. So what is the pressure? Pressure is 1 megapascal. Pressure is how much beta? Pressure is 1 megapascal. And this work is how much? This work is minus 20. So this work is your minus 20 kilojoule. This is all are in kilojoule. So pressure, it is a megapascal, convert into kilopascal. So 1 megapascal conversion in kilopascal. This is also kilo, kg. So this is also kilo. So kilo is 1000 kilopascal into what is final volume? 0.2. What is initial volume? Y. So if you balance this one, the Y value, it is your, if you find the Y value 0.22 meter cube. That's it. Okay. So this is the basic application, how to apply this equation. Okay. So what is the moral of this? What is the cut of the story in short? What is that? There are two things. There are two things. Just add this one. What is that, beta? What is that? First law for the process. For the process. So process heat transfer is equal to change in internal energy plus work transfer. And this is closed and stationary system. Why? Because energy interaction only in the form of heat and work. That means energy interaction only in the form of heat and work. No mass. No mass. That means this is for the stationary closed system. Now, what is this W? This W, if the process, if the process is frictionless, what is the meaning? Internal reversible process. And internal reversible process is your quasi equilibrium process. Internal reversible, a quasi equilibrium process. That means displacement of the system boundary during quasi equilibrium process, the work transfer is equal to integration V1 to V2 PdV. So this is called boundary work. So what is the different name? Boundary work, thermodynamic work, displacement work, or also called reversible work. So this is the moral of the story. Put here this value, find the, what you have to find, you are easily find. Okay, so this is the concept, background of this concept. Now next question. This is 2014. What is that? A closed system. So precisely the system is closed. So what is the closed system? No mass interaction. Volume changes V1 to V2 and heat addition, that means heat is added to the system. That means positive. Heat added positive. The change in internal energy energy given the process, given the pressure volume relation is this one. So pressure is the relation it is given, where V is the volume in meter cube. So what this asking? They are asking the question it is, they are asking what is the change in internal energy in this case? 1 to 2. So what is the change in internal? They are asking. So change in internal energy. What is the change in internal energy? They are asking what is the change in internal energy during this process. That means, see my dear, closed system is there, state first. What is the state first? V1 is your 1 meter cube. State 2, V2 is your 2 meter cube. Volume will change. During that, heat addition 1 to 2 is how much? Positive 2000 kilojoule. The change in internal energy given the process, and the relationship it is given P 1000 into V, and V it is your meter cube. It is not in a specific term. So my dear, apply the first law. What is that? Heat transfer 1 to 2 is equal to change in internal energy plus work transfer 1 to 2. Now there is a closed system and the pressure volume relation it is given, and if nothing to do the work, you can assume the process is internal reversible process. So what is the work transfer? Integration V1 to V2 P dV. So integration V1 to V2, and pressure relation it is given 1000 into V dV. Okay, and V1 how much it is given? 1 meter cube, and V2 is equal to 2 meter cube. So if you solve this one, if you solve 1000 kept outside, and here V square by 2, lower limit is 2 meter cube, upper limit and lower limit is 1 meter cube. If you put and solve, this is your, if you solve this one, this is your, and this is your kilopascal, mind it. This is your kilopascal. So this energy, it is in kilojoule, and this is also kilojoule. So this is your kilojoule. How much kilojoule? So if you write this one, so if you solve 4 to 4 minus 1, this is your 20 kilopascal. Okay, no problem. So this is your 1500 kilojoule. Work is your 1500 kilojoule. Put this value back here. So this is your 2000 kilojoule is equal to delta U plus work, it is your 15. So delta U is, change in internal energy is 500 kilojoule. That's it. Only the application of first law of thermodynamics. Simple. Only the application of first law of thermodynamics. Now next, 2 kg of a substance received. So mass of the substance, mass of the substance is 2 kg. Receive 500 kilojoule. Receive 500 kilojoule. And what is receive? Work receive or heat receive? I don't know up to this point. So the substance is 2 kg. Receive 5 kilojoule. But during the receive, when it receive, its temperature change. So who is the responsible to change the temperature? Heat. So heat is given, and heat receive, that means heat add. (500 kilojoule). During this receive, its energy will increase, so temperature will increase. So the initial temperature T1, 100 degrees centigrade, and it will increase the temperature. Why? Because you add the energy in the form of heat, 200 degrees centigrade. The average specific heat of the substance during the process, a specific heat, C average you have to find. Average specific heat of the substance you have to find it, okay. Simple problem. What is the, so if there is a substance, let's suppose this substance is mass M and you add the energy in this one, you are adding the energy in the form of heat. So if you, let's suppose this system have initial temperature T1, now you have add the energy, this system temperature will increase and it is your T2. Okay, the system mass is your 2 kg. So change, temperature change is there. So what is your C value, a specific heat of this over entire range of temperature. So what is heat? Will add mass of the system, C average into final temperature minus initial temperature. How much heat you are adding? You are adding heat 500. Mass is 2. Average specific heat over entire range of temperature, and T1, T2, 200 minus 100. So if you solve this one, average specific heat of the substance is how much? If you solve this one, this solve 2.5 kilojoule per kg degree centigrade. Yes or no? Kilojoule per kg degree centigrade. So this specific heat, what is the specific heat? A specific heat is the energy content per unit mass basis. See my dear, there are two things, specific heat and heat capacity. There are two different things. So one point is very note down. Specific heat and second one heat capacity. What is the difference in between two? Specific heat is either it is form of Cp and Cv, anything, or simply you can say C. C is the specific heat of the substance, and this C, the unit is joule या kilojoule per kg Kelvin. Joule or kilojoule per kg Kelvin. So this is the energy per unit mass. So if there is any in the container, if there is a water is there and you have a water and that water have a some mass, so according to that mass there have a energy, that is your specific heat. And heat capacity is what beta? If you have a density of that fluid rho, multiply with the specific heat. Multiply with the specific heat. So if you multiply, what is the unit density? Density unit is kg per meter cube. Specific heat unit kilojoule per kg Kelvin. So this kg cancel out. So what is the unit of this specific heat? Unit of specific heat is kilojoule per meter cube Kelvin या degree centigrade. You can write degree centigrade, no problem. Degree centigrade. Yeah, degree centigrade, no problem. Kelvin, degree centigrade, no problem. So, there is a very important thing. This is the energy per unit volume and this is the energy per unit mass. Energy per unit mass is the specific heat. Energy per unit volume is the heat capacity, heat storage throughout a volume. So, if heat capacity is high, if there is any fluid have a high heat capacity, the heat propagation, energy transfer is less. If storage is high, transfer is less. That means what transfer? Diffusivity of heat. Diffusion of heat through a substance of 1 meter cube, let's suppose the volume is 1 meter cube. So if there is a high heat capacity of a substance, let's suppose, if there is a high heat capacity of the substance, the diffusion of a heat, transfer of heat is low. If there is a low value of specific heat, the transfer of heat is more, the diffusion of heat more. So this indicates the diffusion of a heat. Diffusion of a heat. Higher is the higher heat capacity, lower is the lower diffusion of a heat. Lower is the lower heat capacity, higher is the higher diffusion of heat within the material. So that is the difference between a specific heat and heat capacity. Now next question. See this one? This is very good question. What is that? A balloon containing an ideal gas. A balloon is there. Balloon is there. And in this one there is an ideal gas. What is this? Ideal gas. Is initially kept in evacuated. That means it is kept in a vacuum. There is no any pressure is there. Evacuated and insulated room. That means there is a chamber. Let's suppose this is a chamber. And this chamber is insulated. This chamber is insulated. That means there is no any chance of heat transfer. And also there is no any volume. Evacuated, that means there is no any pressure in this one. There is a balloon. There is a balloon kept. Okay, so and balloon contains ideal gas. In this balloon, what is that? Ideal gas. There is a gas. In the balloon, there is a gas, and that gas is an ideal gas kept in an evacuated container, and that container is insulated. That means there is no chance of heat transfer. Okay. The balloon ruptures. Let's suppose the balloon is ruptures. So, balloon is a rupture. That means balloon will blast in the room. Let's suppose the gas will fill to the entire room. Gas will fill to the entire room. Which one of the following statement is true at the end of our process? That means at a stage 2 point. What is that? The internal energy of the gas decrease from its initial value. That means whether its internal energy reduce and the enthalpy remain constant. The internal energy of the gas will increase finally in the room, but the enthalpy remain constant. Both internal energy and enthalpy remain constant. Both internal energy and enthalpy of the gas increase. See, my dear, this question is a very classical question. This is very basics and classical question, and that question is decided by the Joule's experiment. Joule done the experiment like that. That means, what is the situation is there? The situation is that, what is the situation? Situation is that, my dear. What is the situation? Situation is like that. There is a room. So, let's suppose this is a room. Initial state, this is a room, okay. And this room is insulated, and this is a state first. In this one, there is a balloon. In this one, there is a balloon is there. In this one, there is a balloon. Let's suppose this is a balloon. Okay, this is your balloon. In this balloon, there is a gas. And the gas is your ideal gas. Mind it. What is the gas? Gas is your ideal gas. This room is insulated. This room is insulated. That means there is no any chance of heat transfer. This room is insulated. Now, and the room is complete vacuum. That means there is a evacuated room. This is evacuated room, okay. And then this is the state first, and in this one there is an ideal gas. In this one, what is that? Ideal gas. Ideal gas, that means PV is equal to MRT. Okay, this is your ideal gas. Now, then this is state number first. Now it is ruptured, and it is a rupture and fills the entire room. It is rupture and the entire room is filled by the gas. Entire room is filled by the gas. So entire room is filled by the gas, which is initially it is in the balloon. Now the gas will fill in the entire room. Similarly, same thing, in room is insulated. So this is a step number second. This is the state point 2. So this is a state point 2. Now, my dear, this is a state point 2. So this says that whether the internal energy, that means what is that? The internal energy of the gas decrease. That means what is the change in internal energy of this? And what is the change in enthalpy during this process of the room? That means whether U2 will increase, U2 is increase U1, whether you have to check or decrease, whether enthalpy H2 will increase as compared to H1, you have to check. How to check? Now, the expansion, in the balloon there is a gas, and if you rupture, that means you have to puncture the gas. If you puncture the balloon, the gas will fill entire. So the gas will fill entire, that means gas will displaced. Gas will expand. So during the expansion, is there any boundary work? The expansion against a vacuum. Expansion against, this is the classical example of the thermodynamics. If the expansion against a vacuum, the system doesn't do any work. Why? Because there is no resistance. So, my dear, what is the difference between thermodynamic work and mechanical work? That is a very important thing. Someone asks you, what is the main subtle difference between how to differentiate the thermodynamics work and mechanical work? See, my dear, mechanical work is what? Force into displacement. Work is what? Force into displacement. What is the work? Work is equal to force into displacement. That is okay. This is the classical example. This is the classical formula. This is the true. But this work is what? This work is mechanical work or that thermodynamics work. Let's suppose this work F is applied. Applied force. That means if there is a block, and you have to apply a force and the block is displaced through a distance x, let's suppose. So in this one, that is the work is a mechanical work. So this work is called mechanical work. That means the displacement of the system is due to the applied force, that is your mechanical force. But if this force is a resistance force, resistance force applied by the surrounding. That means if I am breathing, so my stomach is expansion. My stomach is expansion against the atmospheric. So that is called thermodynamics work. That means if the displacement against resistance If the displacement against the resistance. So if there is a no resistance force, though there is a force is there, applied force, but there is a no resistance force, no thermodynamics force. So resistance force is there, and due to this resistance force, the work is called thermodynamic work. Thermodynamic work. And what is the thermodynamics work? You know that. Integration V1 to V2 PdV. Now, so the gas will expand, and during the expansion of the gas, there is any mechanism to resist this expansion. That means the expansion, free expansion is there. There is any rock talk. There is a free expansion. So during the free expansion, the thermodynamic work is zero. Though there is a displacement, but there is any work. So work, thermodynamics work happen or not, that will decide by the resistive force. If there is a resistance against the expansion or not. If there is a something will expand, if something, let's suppose piston will displace from TDT to BDT, top dead center to bottom dead center, and that during the displacement, it against a resistive force, in that case the work is done. So this is such type of process is called free expansion or unstrained expansion. That means the process 1 to 2, the process is called free or unrestrained expansion. In this one, there is no work transfer. Work transfer is zero. That is correct. So no work transfer, and also this is insulated, so there is no any heat transfer. So this is work transfer is zero. Why? Because there is a free expansion. There is no heat transfer during the process. Why? Because the room is insulated. So if you apply the first law of thermodynamics, Q1 to 2 is equal to delta U plus W1 to 2. So heat transfer is zero. Why? Because insulated. Work transfer is zero. Why? Because there is a free expansion. So change in internal energy is zero. That means internal energy is constant. So internal energy neither increase nor decrease during the process. Internal energy neither increase nor decrease during the process. Check that. First option is wrong. Why? Because they say the internal energy decrease, wrong. Internal energy increase, wrong. Both internal energy and both internal energy increase. So see, there is one option in which the internal energy constant. See, both internal energy and enthalpy will increase. Internal energy decrease, internal energy increase. So it's like that C option is correct. Why? Because in the C option, internal energy is remain constant. Now we'll check whether the enthalpy is constant or not. That is the very important thing. Now my dear, what is the enthalpy then? What is the enthalpy? What is the enthalpy, beta? Enthalpy, what is the definition of enthalpy? Internal energy plus PV. This is a specific enthalpy. So this is a specific volume, P into V. Now, for an ideal gas, why? Because in this one there is an ideal gas. So ideal gas, internal energy is a function of temperature, strong function of temperature. And for the internal energy equation of a state, P specific volume is equal to R into T. That means it is also function of temperature. So U is the function of temperature, this is the function of temperature. So H is also a function of temperature. H is also function of temperature. Now my dear, if internal energy doesn't change of the system, if the internal energy doesn't change of the system, that means delta U is your mCv delta T. So delta U 0, so delta T is 0. That means what is the initial temperature? Same as the final temperature. That means if the temperature is constant, enthalpy also constant for an ideal gas. That means, hence, what is the conclusion then? Hence, internal energy of an ideal gas did not change even though the volume and pressure changed. Yes, see, during the rupture, if this is your system, so during the rupture, the system volume will change and also system pressure will change. Initially, what is the pressure and volume? Final pressure and volume will change. Though there is a pressure and volume will change, very important information. During this process, pressure and volume changes. So though there is a pressure and volume changes, but the temperature remain constant. That is the Joule's experiment. That is called Joule's experiment. So though there is a pressure and volume changes, the temperature remains constant. That is called Joule's experiment. So beta, hence internal energy of an ideal gas didn't change. Not change. Internal energy is not changing, even though the volume and pressure will change. That means, what the conclusion is that? That means internal energy is not a function of temperature, pressure and volume in the case of ideal gas. That means it is only function of temperature. That's why it didn't change. So during the free expansion, of an ideal gas, both internal energy and enthalpy remain constant. This is your Joule's experiment. Clear, beta? This is clear? So this is the background of this question. So option number 3 is correct. Both internal energy and enthalpy of the gas remain constant. Okay. Now, next question. A rigid container of a volume, the container volume, rigid, what is mean by rigid? In thermodynamics, one term frequently we use. What is the meaning of rigid, beta? The meaning of rigid is no change in volume. That means rigid container, that means change in volume of the tank या container is 0. That is meaning of rigid container. And that container, the volume of tank is how much? 0.5 meter cube. And in this tank, mass of water is there, how much? 1 kg. And this water, it is temperature 120 degrees centigrade. Water is at 120 degrees centigrade. And water specific volume, this is a specific volume of the saturated liquid, and this is the specific volume of saturated gas. The state of the water is, that means you have to calculate the dryness fraction. State of the water is, let's suppose this is a PV diagram. This is a pressure and volume, specific volume diagram. So this is like that. Okay, this is the pressure and volume diagram. Let's suppose this is a constant pressure line. A constant temperature line. This is a constant temperature line. You can say that. This is your constant temperature line. This is your constant temperature line. No, at this point, this is saturated liquid. This is your saturated vapor. So this is your G. This is your V, F, saturated vapor, saturated liquid. And so this is saturated vapor. And in this one, there is any point. So at this point, the dryness fraction is 0. And at this point, the dryness fraction is 1. Okay, the dryness fraction is 1. And in this, so this is F, and there is a point. This point is dry saturated liquid vapor mixture. This is called dry saturated liquid plus vapor mixture. And in this condition, the X dryness fraction is less than equal to 1, so greater than equal to 0. So find the value of X. How to calculate? You know that. What is the volume of this point? So V is equal to Vf plus X of Vg minus Vf. And this is the total volume in meter cube, and this is your meter cube per kg. So also you have to write V by M. So this is your Vf plus X Vg minus Vf. So what is the total volume then? Total volume is 0.5. What is the mass of this tank? 1. Put the value of Vf. What is the Vf? 0.00106 plus X. Put Vg 0.8908 minus this value 0.00106. If you calculate, the dryness fraction is 0.56. That means it is in between 1 to 2. That means this is the dry saturated liquid vapor mixture. Okay. So up to that, I end up here the session, and before that I want to give some information about the IMS. What is that? If you know all this activities, at what time the YouTube activity will start, or any information, join this Telegram group. Join this Telegram group. This is a free of cost. So in this Telegram group, these are the advantages. What is that? Schedule for the YouTube lecture. This is the YouTube lecture type. So the schedule you have, the notification. Also, what is the PDF? Today PDF is there available in this Telegram group, and important updates regarding seminar or webinar, and also the update or notification of the government or PSU job, expert session of important topic like that. This is the expert session of the important topic, and daily cues, and many more. So if you are join this group, all the information you get automatically. So it's my humble request, this is the very intelligent request to join this Telegram group. Okay, no problem. Now the second information is that who is student who are willing to join the GATE 25-26? Who is a student who are willing to join GATE 25-26? These are the features. They may get these things off. That means 8+ hour live classes with the live interaction, theory book, exercise book, and 33 year of GATE exercise book. This is 33 year. Okay, 33 year of GATE questions bank with a video solution, and also there is a personalized one-to-one mentorship, 12 one-to-one mentorship program, and also there is a 130+ test series. So who are willing to join, just book for the free consultation on this number. Okay. And really, if you like this video, so please like, share, and subscribe, so that another one is also benefited. Up to that, thank you. Bye-bye.